All right, now I want to talk about another kind of problem that we're given in trig, and using the unit circle makes it very easy to solve this kind of problem. So let me write down an actual problem and then we can talk about it. It says find the exact values of all x, meaning the variable x, in the interval bracket 0 to 2 pi, close bracket, where cosine of x equals 1/2. So that's a typical kind of trig problem. So they're saying they want you to look at all the angles between 0 and 2 pi, and they want you to go find out which angles would result in the cosine of that angle being 1/2. So it's almost like find the angles where the cosine's 1/2. That's what this problem basically is. Find the angles where the cosine's 1/2. And we're checking all the angles all the way from 0 to 2 pi. So this is where the unit circle really comes in handy. Because you think about the unit circle starts at 0. If you go all the way around, you end up back at 2 pi. So that is basically go all the way around the unit circle and find all the angles where the cosine is 1/2, which really means go find all the points where the x-coordinate is 1/2. Because at each point on the unit circle, the x value is the cosine. So now this is where, if in your mind you know the unit circle, I'm going to go find all the points on the unit circle where the value of x is 1/2. Now, I'm going to show you this chart just to help you understand, but on a test, of course, you would have to be able to do this in your mind. So I'm going to start in the first quadrant, and I'm going to look at all my x values of my points and see if any of them are 1/2. Well, pi over 6, square root 3 over 2, pi over 4, square root 2 over 2, pi over 3, 1/2. Boom. All right, here's a point where my cosine is 1/2, because once again, the value of x is my cosine. So right now, I can start a list and say I know that pi over 3 is a solution. The cosine of pi over 3 is 1/2. Now I need to keep going all the way around the unit circle and see if there are any other points where the cosine of x is 1/2. So now I go to the second quadrant, and I look here. At this point, I notice the cosine is negative 1/2. So the value is correct, but not the sign. So that's not going to be a solution. Matter of fact, if I look at the third and fourth quadrants, the cosines are all negative. So I know right away that I'm not going to have any solutions in the second or third quadrant. However, the fourth quadrant, cosines are back to being positive. So now I'm going to go to my points in the fourth quadrant and see if one of them, if the value of x is 1/2. So I check here right away. This first point in my fourth quadrant, x is 1/2, which means the cosine is 1/2, and that's at 5 pi over 3. So as it turns out, there are two angles, 2 points between 0 and 2 pi that give me a cosine of 1/2. pi over 3 and 5 pi over 3. Let's do another. How about if we say sine of x equals square root of 2 over 2. So once again, what are we looking for? I'm trying to find an angle, or any angles, between 0 and 2 pi, where the sine of that angle is square root of 2 over 2. Or another way to think of it on the unit circle, since the sine of x is, the sine of the angle is like the y value, I'm going to go to my unit circle and see if there are any y values that are square root of 2 over 2. Now the first thing I notice is the sign is positive, so I know I'm going to have to be in the first and second quadrant. The third and fourth quadrant, the signs are always negative. So if I think of the first and second quadrant, and then I have to remember that pi over 4, the sine of pi over 4, the value of y at pi over 4 is square root of 2 over 2. And then I realize that if I go to the second quadrant, and I look at the point that has a denominator of 4 for the second quadrant, it's 3 pi over 4, and I got to look at the y value at 3 pi over 4, and it's also square root of 2 over 2. So now there are two solutions, two angles, where the sine is square root of 2 over 2. Let's do one more. How about the cosine? Let's do this. Cosine of x plus or minus square root of 3 over 2. So now it's saying, go look at all the angles between 0 and 2 pi and see if the cosine of any of those angles equals either positive or negative square root of 3 over 2. So I'm really going to be looking for, when I think of my unit circle, I'm going to go around the circle and I'm going to see for what points is x equal to square root of 3 over 2. And I don't care whether it's positive or negative, so just as long as it's square root of 3 over 2, then that's going to be a solution. So if I look at my first quadrant, I think about it, I realize, at pi over 6, the cosine of pi over 6 is square root of 3 over 2. That's the x value. So pi over 6. And once I realize that, it's going to follow that basically in all my quadrants, I'm going to look for the angle where the denominator is 6. So in the second quadrant, that point is 5 pi over 6. Turns out the cosine of 5 pi over 6 is negative square root of 3 over 2. Then I keep going around, I go to my third quadrant. Once again, I'm looking for the point in my third quadrant where the denominator is 6. Turns out it's 7 pi over 6. And then I get to the fourth quadrant. In the fourth quadrant, I've got this point, 11 pi over 6. So there are actually 4 solutions. There are 4 different angles between 0 and 2 pi that cause the cosine to be plus or minus square root of 3 over 2. And just so you can see it visually, here's my unit circle, and I realize square root of 3 over 2 is right here at pi over 6. So once I know that, then I can go all the way around the unit circle, and everything with the denominator 6 is going to be the points I'm interested in. So when I go to the second quadrant, my point is 5 pi over 6, and there's the cosine, negative square root of 3 over 2. I go to the third quadrant, I'm still looking for denominator 6, and there we go, 7 pi over 6. The cosine is negative square root of 3 over 2. And as I keep going around to the fourth quadrant, here's my point again, 11 pi over 6, and the cosine is square root of 3 over 2. So I'm just telling you, it may be a little work up front to try and memorize or to sort of map out this unit circle, but in the long run, it's going to really make it easy for you to solve lots of different kinds of trig problems. And that's why they teach the unit circle and encourage you guys to understand it.